Hello, my friend. How are you doing? Hope you have a great day. Today we are going to do something totally new. We are going to make a retro or PS1 shader completely from scratch. First make changes to the Wicked shaders and then get them into GameGuru MAX. But I just want to explain why I made a new program is because the old workflow for this was you had the repo open in Visual Studio and you made your shader changes there. And then it needed to compile all the shaders, and from there you got into GameGuru MAX, booted that up and started GameGuru MAX, loaded the level you wanted to check, and then you could see your shader changes. That whole process could take 3 or 4 minutes, so each time you make a change you have to go through all that waiting, and that's why I started making something called Minimax, just to show you what Minimax is. Yeah, it is what it says, the name is Minimax. Like so. If you look at this, it's the complete default terrain of GameGuru MAX that has been loaded and functional and running in the under 2 seconds. And that is amazing. 2 seconds to get everything up and running. And sure, everything is working as it used to. So it's extremely fast, and sure it is able to also, you can just double click a FPM file and we'll launch Minimax and show you the level. This is the level. You can see it will load it up, the terrain and all the textures in 2 seconds, and then the FPM took 3 seconds to load. That's because I added a lot of threading, and all DBOs is loaded in a thread and all images are loaded in the thread at the same time as it goes through all the objects and create them and do stuff like that. So it's incredible fast. And it was just the idea I got the other day that this one, the LST file that are part of that GameGuru MAX save, each time you save your level in GameGuru MAX, it creates this file. If you look at this file, you can see it has all the FP, DBOs, DDS files that are used in the complete level. So before I even begin to load the FPM, it will read in this file and immediately start all the thread loading of the DBOs and all the images. And another thing, it sounds weird, but one of the slow points in GameGuru MAX is all the file checking. It do a lot of checking if files exist, and around 20% of the time used was to check if file existed and whatever. So it also has a thread to resolve these file checks, and so they are also instant now. So it is really fast. Oops. And you are inside Max, 2 seconds. But that's not what we are going to. What I'm going to show you is how to make a shader. And what I did in the Minimax code is to add all the DX12 Wicked shaders. They're here. So they compile from inside Visual Studio and inside Minimax. You can see here it just set up to shader model 5, and it will compile it and make all the GameGuru MAX shaders and all the Wicked Engine shaders available to Minimax. So it will load all of them from there, and you can check all your levels using it with the new shader changes. So that's pretty great. But let's get started. We'll make the retro shader here inside the tone map compute shader. That's a Wicked shader I just added here. So let's start. Let's define. Oh, we can just try the level from here. will take a little longer time because it's have a debugger running, but from the old workflow where I had around 3-4 minutes for each test run, you can see here there's a big difference. Just try again. Should have cached something now. Loading. Well, took 3 seconds. This is because the debugger is running this a bit more slow, and the FPM loads at 5. So that's 9 seconds we need to use each time we make a shader change. But compared to the old 3 or 4 minutes, that's brilliant. So let's just define pixel shader. First thing we'll do, perhaps make a pixel size for a start. Make it 16 pixels. Just copy this and find a place to make the code. This is the underwater way where I made using the old way with the 3 minutes wait each time. So well, we're just going to place it right here about. So we are going to change the UI, so it's a good place. It's a little bit strange, this Visual Studio shader editor, but so the first thing we are going to do is to, let's see, we are going to take the resolution and cut the UV so they always fit into the pixel size. So let's see, what are we doing? Float. What should we call it? New UV? No. Pixel pose could we call it. It should be equal to, this is the actual pixel pose position. So we will just take that, and then we are going to multiply this with the pixel size we want, and then we are going to floor it. This will it will round down to the nearest. I don't know why this editor is. Oh, I'm missing this one. So now we have it rounded down. So now we can divide it again by the pixel size, which should give us the pixel size that we want. Was it? We set it to 16. Let's try it. Oh, we forgot to assign the UV to the new pixel position, so that is not going to work. And that's why all these changes, try to keep a count of how many times we are trying to, we are starting up GameGuru MAX or Mini MAX, and then at the end you can see how much time we are using. This one we are just going to calculate by a new position, the principal plus 0.5f. Why we add the 0.5s is because we want to get to the center of the texel. So that's why. And then we take the resolution. Can use this to cut it down, so the UV, it will always be in the range of 0 to 1. And Let's try it. So now it's good. It should align the UE to the pixel position, new pixel position. Let's see what happens. Loading. Oh, that's something is wrong, but it's doing something here. Let's see what is wrong. Oh, wow. Sure, it's wrong. It should be a float 2. That's called. It is a float. This is a U integer 2. So sure, we need both x and y. But that's what's happening when you're doing it real time. So I don't see anything. Strange. Why don't it work? It should work. What is wrong here? We're doing it wrong. We should truncate it and then expand it later after it's been floored or rounded down. So we need to do it this way. Divide it first, and then floor it, and then multiply again, so we get even numbers. So everything fits the 16 pixel. Oh, that's better. Now we're starting to look at something. That's kind of look pretty nice. I think it's too large. Perhaps we should just put it down to, what, 10? Depending on what we are going to emulate. If this was a console, oh well, perhaps 10 pixels per dot is a console. Let's see how it looks. Loading. Remember to keep count of how many times we restart this. It's still too blocky. Let's lower it to, well, perhaps 6. Check it again. Now the old way, I had to wait 1 minute for Wicked Engine to compile all shaders and a few minutes for Max to start up, and before I loaded my level, and so this is really a time saver. Okay, it's still too large. Just try to look around, but it looks great. See those cactuses? Oh, it's got really. It's a little noisy here. First, let's check. We need to make it smaller, perhaps 4. Let's just check that out. And then we have to try and fix some of that color shifting we get when we move the camera. So we need to even it out. Loading. Okay. Oh wow. Check this fire. It looks great. Let's try to move around a little here. See, there's a lot of flickering when I rotate the camera. Not as much up here, but okay, we can try to remove some of that. What I would do was just, depending on how much FPS you want to use to make a good looking pixel shader, then we could just check out where is it sampling here. It's getting the HDR texture color. Let's make, oh, sorry, gypsum. Like so, copy this one up top. And then when we are compiling with a PC shader, what do we want to do? We want to sample from neighbors also, so we could do no, -1 until x is larger or equal to 1, x plus plus, increase by 1 each time. Do the same for the y. Oops. So we have a loop. Now we are going to, what we need here is the fixed UV position first. So we always start at the same location. And that is just the UV now. So we're going to use this. And we are going to make a new one. New UV should be equal to old UV plus, and then we're going to add these position into it, which means we are converting the integers into a float 2 with the x and y. So we have a float 2 now, which is not actually the texel size because but it's one from. So what we need to do is now convert it into the actual texel size to get the correct UV. So we will just take the resolution RCP, because it will, if we multiply it by that, it will be changed into the correct texel size. So we done that. So now we can say we don't want to sample, we want to add to it, and HDR should just start at 0. Yeah, let's try that. Show it will sample the 9 neighbor pixels, so it should be, the color should be a little more stable. Oh, wow, well, we forgot to divide it again, so it's probably going to be bright. Oh, or black. Okay, well, oh, we need to use the new UV here, and we also need to divide it by 9 as we do 9 samples. Right here, let's try again. And see what happens. Ah, we still have a bug. What are we doing? Oh, same problem again. This need to be a float 2, of course. It's a UV coordinate, so let's see what happens now. Nothing. That is strange. What are we doing wrong here? I don't really see anything wrong. Why don't this work? We are getting the fixed UV and making the new plus float 2 gange. That should be correct. So I'm not really sure what is going wrong here. Claim UV, that should be fine. Yeah, well. Well, yeah. Oh, should be less. My bad. Let's see what happens. Come on. Okay. Yeah, okay, that looks a bit better and less flickering. Sure, if you want it more stable, you can always, it looks pretty good. You can always increase the loop here, depending on how many samples you like to use on it. But I'm happy with this one, so let's try to see what else can we do here. What about the palette size, the colors? We could, we could define palette size, how many colors we want. What should we say, around 20 colors in each channel. And by saying so, let's just copy this and oops, change the HDR right here, change the colors. Slowing time, blah blah blah. No, yeah, something is wrong with it, but that's okay for now. I don't know why it's so slow now, but sure it is. Perhaps because I'm recording. We have our palette size. So what we do with the HDR colors is to, let's think, we can just reduce it by the size, which then give us some colors that we can round down. Oh yeah, it's pretty slow, and then move it back. That should give us what we want. Oops. Let's check it out. If it reduces the color palette. Let's see what is happening. Oh, we are black again. What did we do wrong this time? Yeah, okay. We are completely removing it here. So we are going to do it the other way around. Which again would give us those values. That's better. It's a little hard to see. Okay, you can see it here, but yeah, it's because it's pixelized now, so it's a little hard to see. We can just try to remove the pixel stuff, so we only have the palette size. And see how it looks. Loading again. It's many time. We are doing this many time. Okay, let's see how the palette looks. Yeah, it is reducing it some, but not enough. Let's reduce it further. Let's just reduce it to around 14. Oh, let's try some low numbers. 4. When we write 4 here and we do it like we do, then we will get in each red, green and blue channel, we'll get 4 colors in each channel. So, okay. So now we only have 4 colors in each channel, and you can see it here up in the sky. That's just too little. Well, we need to increase it. What about 8? How do that look? Come on. 8 colors per channel. I'm not sure what is equal to. You have to, depending on what you're emulating, you need some different numbers. Okay, here we have, what was it, 8 per channel. And it's starting to look okay. I think we need a few more. 12 perhaps. 12. I'm not sure how many the PS1 had, how many colors, but let's see here. Okay, that looks pretty retro. We have some red there. I'd like to give it a little more. 14. Check it out before we enable everything. Loading again. How many times have we done it now? Let's look at the sky here. Yeah, we can see it's a pretty good look. And then if we combine, yeah, you can also see here over the water. And here, if we then combine it with our piece of stuff here and here, we should have something that look pretty retro, pretty PS1 or something like that. And here we go. So, it looks pretty good, I think. Actually, I just think I will make the block size smaller. It do look too blocky. Let's see it here. We just change it to 3 perhaps. See if that looks better. Let's see how it looks. Yeah. Let's look at the sky. Yeah, we have the color graded there. And the pixel is fine. The pixel size. If we look here. Yeah, I think this pixel size is fine, and we have all the reduced colors, so it looked pretty old style. Yeah, I like this one. So what I will do is I will put the changes we just made, the source file, onto the Patreon Discord server, and I will also compile a complete folder, all the shaders, so you can, if you don't want to compile all the shaders yourself and make it, then you can just use this. And so I will put in the shader folder that you can use to replace and use in GameGuru MAX. So and sure, it will be free for all supporters. So thank you for supporting my work, and until next time, have a great day.